Relax afternoon fishing for our friends. Unfortunate, they don't catch anything today. Looks like they got something big. Something huge. Let's talk about Docker. Docker is an open source platform that enables developers and DevOps engineers to build, deploy, run, update, and manage containers. Okay, but what is a container? Containers are standardized, executable components that combine application source code with the operating system libraries and dependencies required to run that code in any environment. Or, in other words, encapsulate all your dependencies and configuration that take several hours to set up in an easily deployable environment. With Docker, you can forget about managing multiple engine versions, dependencies requiring a specific version for each project, and other configuration needed to run things like database engines or similar services. Well, but this sounds like a virtual machine, right? Nothing new over here. Looks like a virtual machine, but it's not one. Containers have many differences from virtual machines. For example, containers are lighter than VMs because they don't have their own operating system, unlike virtual machines. Instead, containers share the host kernel, meaning they use the OS core of the computer where they are running. Since containers don't create a full operating system, some functionalities are limited. For example, they may have difficulties accessing certain hardware devices. Additionally, it is easier to implement compared to virtual machines. Okay then, what we need to start? First, understand three key concepts: Docker image, Dockerfile, and Docker Compose. We can compare this to an engine. Yeah, an engine. We start with Docker image, which is a lightweight self-contained package that includes everything needed to run your software: code, libraries, dependencies, and configuration. It is also ready to use with the Docker engine. Let's get back to our engine. We can have a Docker image for a fully assembled engine piston, or perhaps for a fuel pump with all its electrical components, both ready to work. But what if you want to build your own engine parts? Well, you can do it with your Docker file that contains instructions for generating a Docker image. Basically, it's the source code of the image. A bit of metal, electrodes, glue, and voila, we have a spark plug ready. We will need a lot of glue to join all these pieces. Or you can take an easier approach and create your software entirely with a single Docker file. For this, you can use Docker Compose, which helps you define and manage multiple containers simultaneously using a single configuration file, the dockercompose.yml. On this one, you can define things like network configurations, data volumes, environment variables, dependencies, and so on. Okay then, let's build our engine. Put a piston with some commands, a fuel injector, and the spark plug with his dependencies. Well, kind of. It will be better to use an example with software, maybe a backend service that depends on a database, a frontend running on port 80,000, and a RabbitMQ service for queues. Or take a look at this Docker Compose example, extracted from Selenium Docker image on Docker Hub. By the way, what's Docker Hub? It is a container registry, a place where you can find third-party Docker images, or upload your own. There are other options for this as well, such Amazon ECS or Azure Container Registry. Docker is an incredibly useful tool that has become the standard for encapsulating environments, simplifying work in complex setups and CI/CD workflows. Make sure you don't miss the chance to add Docker to your toolkit. Don't forget to give it a like and subscribe for more. Thanks for watching.